All right, so we are looking at, this is CC3, and this is CC3. It is section 3.1.7 and number 66, 366. Okay, so we have a situation where we got a couple rules here that we need to make a table, an X and Y value table, and then graph the rule on graph paper. And then there are going to be some questions about those two situations. So let's start this off. Our first one for part A is y equals x squared. All right, so when we graph that, again, I'm going to go with finding some values that are positive and negative. So in this case, I'm going to use -3, -2, -1, 0, 1, 2, and then +3. All right, so I'll have those as my values. When I plug those into x squared, remember x squared simply means it's x times x. You're taking the same number and multiplying by itself twice. So in this case, -3 times -3, right? So I'm multiplying -3 times -3, and I'm going to get a +9. -2 times -2, I'm going to get a +4. -1 times -1, and I get +1. 0 times 0 is 0, and then 1 times 1, 1, 2 times 2 is 4, 3 times 3 is 9. Okay, so this is our values for the x-axis, for the x squared. And now looking at it as a graph, if I see I'm on my x-axis going from -3 to 3, and my y's from are as high as 9 and as low as 0. So I'm going to take my axes and get some appropriate scaling going on. So we'll go as high as 9. So I'm going to take it down at least 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll do it there. Make sure I'm over 1, 2, 3, 4. That's good enough. So I'll put my origin right there. I'll get my axes looking good. Use my straight edge. So there's my y-axis. And oops, I ran off the paper there. Let's try that again. My y-axis. And keep in mind your axes, right, continues. So I'm going to have that up and down arrows. And my x-axis, upside down, there we go. I will get my x-axis on there. And once again, the axes do continue. They don't stop just because you ran out of ink. So in scaling, in this case, I'm going to scale it by 1s. So I'm going to mark that so I can see that I'm going by 1s. And I just have to, in one direction, go show that I'm going by 1s. And that automatically tells me that in the other direction I'm going by 1s. So now let's graph our points. Start with -3, 9. So -3 on the x-axis, 1, 2, 3, right? That's -3. And then on the y-axis, we're going up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's at 9. Okay. And maybe it might help if you want to. If you just had 1, 2, you could do it, maybe the evens on your way up, so you don't have to count all the way up to 9, but not so bad. -2 to 4. So -2 on the x, 4 on the y. -1 on the x, +1 on the y. 0, 0, that is the origin. That's right in the middle. And then 1, 1. And then 2, 4. And 3, 9. And what are we looking at here? So we've got, it's not linear, right? In this case, this shape, when you see this pattern, and you notice it's going up and it's getting steeper as it continues to climb, and as it gets to that vertex. This is called the vertex. This is a parabola, right? So it's a kind of a U shape, not a V. It's a U, and it continues to travel in that direction. So we put arrows to show that. So this is y is equal to x squared. Always label then the rule next to the graph. And we connect the dots. Again, why do we connect the dots? Connect the dots so that we know that in between this value of 1 and 2, where the x is 1 and 2, there are values of y, right? I could put 1.5 in here. I could put a 1.5, 1.5 into the x. 1.5 is going to get me 2.25, which would be right about there, right? So I see that on my graph, and that's why I connect the dots to show that there's values in between each of the integer values. All right, so there's that first one. So let's get into B. So let's graph and do B. So B is y is equal to negative x squared. So I'm going to use the same set of values for that one. So I'm going to use -3, -2, -1, 0, 1, 2, and 3 for my x values. Keep in mind, what does this mean? This means negative x times x. Or even further, that negative in front is saying -1 times x times x. When you have a negative in front of a variable, just a negative, it's really a -1. Or you can even say the opposite of that. Negative also can be known as opposite of. And when you have a -1 times anything, it does change its sign to be the opposite of what it was. One of the misconceptions, folks, that I see happening is folks see this as, and I'll write it over the side and then it'll disappear, but just so we can see it, see this as -x times -x. And that's not the case, right? -x times -x wouldn't be this because that negative is not included with the squared. If I had -x squared, if that was the function, if y equals -x squared, then it would be -x times -x, the opposite of x times the opposite of x, if it was in parentheses. But in this case, it's not. So just that squared is only dealing with the x. Okay, so let's continue on. So what does this mean? -3, you put -3 in. So what we have to do is we're multiplying -3 times -3, then we're doing the opposite of it, or -1 times that. So -3 times -3, we already did that over here, was 9, but now it's the opposite, or times another -1 makes it a -9. So notice when I put a -2 in, -2 into the x squared, it's still -2 times -2, which, like we did over here, was 4, but it's got that negative in front of it, so it's the opposite, or we can say multiply by another -1. So again, -1, we put that in. So really we have a -1 times a -1 times a -1, which gives us back to being a -1. So notice the pattern here, and then a 0, 0 times 0 is 0, but there's no such thing as -0, so it stays as just 0. And then 1. Now if I put a 1 in, I'm saying 1 times 1, but then the opposite of 1 times 1. 1 times 1 is +1, so the opposite of it would be -1. Or 1 times -1 to get that -1. Putting in 2, right? We're looking at -1 times 2 times 2. So it's the 4 times -1, which is -4. And the last one, 3. 3 times 3 is 9, times -1 is -9. All right, so let's graph that one. So I'm going to fold out the first one we had so we can see it when we're done side by side, but let's see what we've got here. This time I'm looking at, I'm going from -3 to 3. So again, on my x, I could have my x-axis from -3 to +3, but this time the y's are as low as -9, but only as high as 0. So really my origin, I could sit way up here. I don't have any values in the positive, so I'm gonna just go ahead and put my origin up a little higher, but I want to make sure that my y-axis goes down at least to -9. And then my x-axis is from -3 to 3. Okay. Again, on your axes, throw some arrows so you know, and the reader knows that axes do continue. I'm going to label. I'm going by ones again. So 1, 1, and that's 1 and 1. So really this is going in the negative direction. So -2, -4, -6, -8 is what I have as far as in the negative direction. Again, -1, -2 for the y, or the x in the x direction. So let's get our plots pointed, or graphed, or plots pointed, our points plot. So we have -3, -9 right down here. So -3 on the x, -9 on the y, -2 on the x, -4 on the y, -1 on the x, -1 on the y, another 0, 0, so my origin there, and then +1, -1, +1 on the x, -1 on the y, +2 on the x, -4 on the y, +3 on the x, -9 on the y. So I have another shape that is this U shape, but it's upside down now. So if we see the trend here, this kind of curves slowly here, but then it continues to curve, but in a much rapid rate. So I'm going to connect it like a U. And again, we have a parabola with its vertex at 0, 0. And I'll label this one y is equal to -x squared. Okay, so we've got our two graphs. I'm going to unfold so we can talk about our two graphs, because now they want us to compare the graphs and talk about what we notice. So for part C, compare your graphs and what do you notice? So for part C, we're going to compare the graphs and what do we notice? Well, first of all, they're both parabolas, right? They're both parabolas. But what do we notice, right? A opens up and B opens down, right? Do you see that? So A opens up and B opens down. Okay, so there's a couple things. There's other notices we could put in here. We can notice that the vertex is at the same. Okay, same. I'm going to say that same vertex. Right. So these are some notices. Both parabolas. A opens up, B opens down, same vertex. Those are different things we notice about the two graphs. So part D, for the graph of y equals x squared, that's this one, estimate the x values corresponding to y equals 5. So how do we do that? If I'm looking for where y is equal to 5 on this value, so if I look y equals 5, 5 is right here, that's where y is 5 on the axes. So where is it on the x? Well, if we bring it over, it's going to be somewhere right in here, but I have to notice that it's got two x values at y equals 5. So when, and we could say then, I'll write it here, when y equals 5, x equals what? Well, let's take a look. If I bring my estimate down, it looks like maybe 2.2 maybe. And then if I do this one down this direction, where is that? Well, if that's -2, then that would be maybe -2.2 as well, or -2.3 even. So I'm going to go ahead and say x is approximately, and we're going to use the approximate sign instead of an equal sign because I'm using the graph to approximate. I don't have the exact answer from the graph. So I'm going to say approximately 2.3 and -2.3, right? So when y equals 5, x is approximately 2.3 and -2.3. It's got two values. Okay, so then what about E? It says for the graph of y equals -x squared, estimate the x values when y is equal to -10. So let's look where -10 is on my other graph of y equals -x squared. So I want to know where's y equal negative 10. Negative 10, this is negative 8, this is negative 10 right here. So negative 10 would be here. So if I bring it over, I'm on that point there, and I bring it over, I'm on that point there. So a little trickier, I can follow it down, and it looks like it's following along just above where x is 3, right? So that's where x is 3. So maybe we'd say 3.1 or 3.2 even, and then I could even do the same thing down this direction, right? And I take that and follow it on my graph paper. That's why it's important to have a nice graph using graph paper, because then you can follow your grid lines. So again, that's negative 3 right here. So this would be negative, say, 3 point, maybe 3.2, 3.1. I'll say 3.2. 3 point, and this is positive 3.2 on that. So we would say when, and this is for E, when y equals 10, oh, excuse me, it's negative 10. When y equals negative 10, x equals, or is approximate. Again, I want to say approximate because I'm using my graph to approximate my value. So use the squiggly equals. X is approximately what? Another way of writing, you notice it's the same number. It's 3.2, right? But it's a positive and negative 3.2. So you can actually do the symbol positive or negative 3.2. So you could write it in two different ways. You could say x is approximately 3.2 and negative 3.2, write it twice. Or you could say x is approximately positive or negative 3.2. All right, there we go. I hope that helps.